This is SpaceTime, Series 28, Episode 149, full broadcast on the 19th of December 2025. Coming up on SpaceTime, the earliest supernova ever seen. New clues suggest that liquid water, and consequently the potential for life, could still exist on the red planet Mars today. And the great Geminids meteor shower of 2025. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers have detected the earliest supernova ever seen, dating back to a time when the universe was just 730 million years old. The observations, reported in the journal Astronomy and Astrophysics, were made using the Webb Space Telescope. The exploding star, catalogued as GRB 250314a, emitted a super bright flash of light known as a gamma-ray burst. The detection broke the previous supernova distance record, an event dating back some 12 billion years. The study's lead author, Andrew Levin from Radboud University in the Netherlands, says this new detection shows that astronomers using Webb can find individual stars when the universe was just 5% of its current age. While a gamma-ray burst typically lasts for just seconds or minutes, a supernova rapidly brightens over several weeks before it slowly begins to dim. In contrast, this supernova brightened over months. Since it exploded so early in the history of the universe, its light was stretched as the cosmos expanded over billions of years. As light is stretched, so is the time it takes for events to unfold. Webb's observations were intentionally taken 3.5 months after the gamma-ray burst ended, since the underlying supernova was expected to be brightest at that time. Gamma-ray bursts are incredibly rare. Short-period gamma-ray bursts can last for just a few seconds and are thought to be caused by the merger of two neutron stars creating a black hole, or alternatively by the merger of a neutron star into a black hole. On the other hand, long-period gamma-ray bursts can last around 10 seconds and are thought to be caused through the explosive supernova deaths of massive stars resulting in the formation of a black hole. As for this event, the first alert was sent out back on March the 14th. News of a gamma-ray burst from a very distant source came from SVOME, the space-based multiband astronomical variable objects monitor mission, which is designed to detect brief transient events like gamma-ray bursts. Within 90 minutes, NASA's Webb Space Telescope pinpointed the X-ray source's location in the sky, and that enabled subsequent observations to pin down the distance for Webb. 11 hours later, the Nordic Optical Telescope on the Canary Islands was queued up and revealed an infrared light gamma-ray burst afterglow, an indication that gamma rays might be associated with a very distant object. 4 hours later, the European Southern Observatory's Very Large Telescope, the VLT in Chile, estimated the object existed just 730 million years after the Big Bang. Levin points out there have only been a handful of gamma-ray bursts in the last 50 years that have been detected during the first billion years of the universe's existence, and he says that makes this event both very rare and very exciting. Since this is the earliest and most distant supernova ever seen, astronomers compared it to modern-day, more nearby supernovae. Amazingly, the two turned out to be very similar, and that surprised scientists because very little is known about the first billion years of the universe's existence. It's thought that early stars likely contained far fewer heavy elements, they were more massive, and they led far shorter lives. They also existed during the epoch of reionization. That's when the gases between galaxies was largely opaque to high-energy light. But Webb showed that this supernova looked exactly like modern supernovae. Before researchers can determine why such an early supernova is so similar to nearby events, more data will need to be gathered in order to pinpoint tiny differences. The Webb observations also indicate that the distant galaxy from which the supernova originated was also similar to other galaxies that existed around that same time. Since the galaxy's lights blended into a few pixels, making the galaxy look like a reddened sponge, astronomers are still limited in exactly what they can learn about it. Still, seeing it at all is a major breakthrough. This is SpaceTime. Still to come, new clues suggest that liquid water, and consequently the potential for life, could still exist on the red planet Mars today. and how to observe the great Geminids meteor shower of 2025. All that and more still to come on SpaceTime. A new study based on seismic data suggests that liquid water and the potential for life could still exist beneath the surface of the red planet Mars today. The findings are based on a new evaluation of marsquakes recorded by NASA's Mars InSight lander, which touched down on the red planet in 2018. This lander used its robotic arm to place a seismometer on the Martian surface, designed to measure seismic waves generated by meteor impacts or Martian geologic activity, and thereby providing a picture of the planet's interior. One of the study's authors, Iku Katayama from Hiroshima University, says the new interpretation of this seismic data does suggest the presence of liquid water below the surface. And if liquid water does exist on Mars, that would present a habitable location for microbial activity. That is, if life does exist on the red planet. When a Marsquake, or for that matter a meteorite impact, occurs, InSight was able to read that energy, emitted as P waves, S waves and surface waves, allowing it to create an image of the planet's interior. Scientists can use the P waves and S waves to determine a lot about the rocks that make up Mars, including the density of the material or potential compositional changes within rocks. For example, S waves can't travel through water, and they move at a much slower speed than P waves. Therefore, the presence, absence and arrival time of S waves can determine what the subsurface looks like. P waves travel faster through high-density material and slower through less dense stuff, so their velocity can help determine the density of the material they're travelling through, as well as if there are any changes in the density along the way. The seismic data collected by InSight shows boundaries at a depth of around 10 kilometres and at 20 kilometres based on discrepancies in the seismic velocity. Now, these boundaries had previously been interpreted as sharp transitions in the porosity of rocks or the chemical composition of the Martian interior. However, Katayama and colleagues have interpreted these cracks as potential evidence of water within the Martian subsurface. They say the seismic data indicates a boundary between dry cracks and water-filled cracks in the Martian subsurface. In order to test the hypothesis, the authors measured the seismic velocity passing through rocks with the same structures and composition of typical Martian crustal rock under wet, dry and frozen conditions. Typical Martian rocks are similar to the diabase rocks found in Sweden due to their evenly sized plagioclase and orthopyroxene grains. In the lab, Katayama and colleagues measured P-wave and S-wave velocities using a piezoelectric transducer, which uses electrical energy as a wave source that monitors seismic wave energy on dry, wet and frozen diabase samples. Their work showed that the seismic velocities of the dry, wet and frozen samples were significantly different. That supports the idea that the boundary at 10 kilometres and 20 kilometres could be caused by a change from a dry rock to a wet rock. These laboratory experiments back up the hypothesis that the boundary measured by seismic data indicates a transition from dry to wet rocks rather than a change in porosity or chemical composition. Katayama says the findings therefore provide compelling evidence for the existence of liquid water beneath the Martian surface. This is SpaceTime. Still to come, the great Geminid shower of 2025. And later in the science report, a new study shows that the family house cat will meow more frequently for male caregivers than female ones, and the study's authors think they know why. All that and more still to come on SpaceTime. One of the most spectacular meteor showers of the year is now at its peak, giving sky watchers a chance to see up to 100 meteors an hour under perfect conditions. The Geminids are visible between now and December the 20th. They're considered to be one of the best and most reliable annual meteor shower events. They were first observed in 1862 and are thought to be intensifying every year. Most meteor showers are caused by comets, but the Geminids are unusual because they originate from a debris trail left by an object known as 3200 Phaeton, which is more likely an asteroid. Rather than being white like other meteors, the Geminids have a distinct greenish hue when they burn up in Earth's atmosphere. That's because their chemical composition, oxygen, magnesium and nickel, usually produce a green colour. Meteors are small pieces of interplanetary debris which burn up in Earth's atmosphere after coming in at high speeds, typically around 130,000 kilometres an hour in the case of the Geminids. Friction in the upper atmosphere quickly heats up the incoming debris, the air around them glows brightly, and the particles are rapidly destroyed. The resulting streak of light is what we see on the ground as a meteor, often incorrectly referred to as a shooting star. Robert Massey from the Royal Astronomical Society says the best way to see the Geminids is in dark skies, well away from any light source. He says you can expect to see perhaps 100 meteors an hour, and that means around 1 or 2 every minute.
So the Geminids are a meteor shower, and in this particular case, they all appear, if you trace the meteor's paths backwards, to originate from a point in the sky in the constellation of Gemini near the bright star Castor. And like other meteor showers, they're connected with a particular celestial object. Now, most meteor showers we connect to comets. In this particular case, they appear to originate from the asteroid 3200 Phaethon, which could be a weird example of something called a rock comet, which is putting debris into the solar system, and once a year the Earth runs into that debris, it burns up in the Earth's atmosphere, and that's when we see a meteor shower. With meteors, what you're going to expect to see is something that you might regard as a shooting star. In other words, a short streak of light that generally lasts maybe half a second or so, usually so quick it's impossible to point out to someone you're with, so you need to keep your eyes up. The advice on looking for them is to get yourself something comfortable to actually lie down on or sit down on, so take out a sun lounger and then simply look up at the sky. Now, the best view is if you're away from sources of light pollution, so try and get away from at least direct lights in towns and cities, ideally out in the countryside. Obviously, you also need a clear sky. If it's cloudy, you're not going to see anything. And then really you're looking up at the sky and you expect to see perhaps, if we're lucky, up to 100 meteors an hour. So that might be 1 or 2 a minute, which would be a brilliant view. It is one of the strongest showers of the year. The great thing about a meteor shower, including the Geminids, is that actually the naked eye is the best way to see them. If you get a telescope or a pair of binoculars, you're automatically restricting your view of the sky. And with a meteor shower, what you want is the widest possible view. You want to be lying down, looking up at the broad panoply of stars, if I can use that expression, and watching for meteors. By far the best way to do that is with the naked eye. Now, some people are really, really good at taking pictures of these things too, either with all-sky cameras or they get lucky, they've got cameras set up on tripods and they snap them over a period of time. If you do manage to get some photos, please share them.
That's Dr. Robert Massey, the Deputy Executive Director of the Royal Astronomical Society. And this is Space Time. And time now to take another brief look at some of the other stories making news in science this week with a science report. A new study has shown that drinking 3 to 4 cups of coffee a day might slow down the biological aging of people with severe mental illnesses. The findings, reported in the British Medical Journal, show that coffee can produce an additional 5 extra biological years by lengthening telomerase, a compound structure at the end of chromosomes which acts as an indicator of cellular aging. While telomere shortening is a natural part of the aging process, it seems to be accelerated in those with major psychiatric disorders like psychosis, schizophrenia, and bipolar disorder. A recently excavated site in Pompeii may have solved one of the great mysteries of Roman cement. The site appears to have been under active construction when it was suddenly abandoned in the year 79 due to volcanic activity. Now archaeologists say the rare find of construction tools and raw materials at the site has allowed them to better investigate how the Romans were making cement at the time. They found materials including limestone and volcanic ash, which supports the theory that they used a technique called hot mixing. Mixing dry heated limestone with water and volcanic rocks and ash created a chemical reaction that heats the mixture. A report in the journal Nature Communications says weights and measurement tools were also found at the site, likely used to help keep ratios consistent and walls level and straight. A new study has shown that the family house cat meows more frequently when male caregivers walk through the front door compared to female ones. The findings, reported in the journal Ethology, are based on studies involving 31 domestic cats and their human companions. People were asked to film the first few minutes of returning home while behaving as naturally as possible. The authors then analysed just the first 100 seconds of each recording, tracking 22 specific behaviours. These included the number of meows, head rubbing against a person's leg, and stress-related behaviours like yawning. After analysing hundreds of chirps, one thing stood out clearly. Cats vocalise far more frequently, that is meows, purrs and chirps, when greeting male caregivers compared to when they were greeting female ones. And they found this increased frequency was the same right across the board, regardless of the cat's age, breed, sex, or even the size of the household. They found that on average, cats produced 4.3 meows in the first 100 seconds of greeting a man compared to just 1.8 meows when greeting women. Now, the authors think the reason's pretty simple. Male caregivers tend to talk less with their cats and are generally less attentive. Consequently, cats need to use more vocal signals in order to actively elicit responses from them. A pair of alleged scientists who claim to be experts in the field of precognitive neuroscience claim that gut feelings are actually memories from the future sent back to the present day through some sort of quantum effect. But as the skeptic's Tim Mendham points out, as soon as pseudoscientists bring out the term quantum, you know they're talking a load of garbage.
There's two people quoted in a recent story, and both of them work at something called the Institute of Noetic Sciences, and that was set up by a pro-paranormal group. Noetic means of the spirit or paranormal or something like that. So it's definitely what we would regard as a wooish institution. They come to their research from the point of view of believing.
Funny, they don't look wooish.
Both of these people, I got a quote from an article, they want to show the validity of precognition through statistics. In other words, they've already got the belief and they just want the data to prove it. A belief in something which is highly dubious, so they've already got a belief and they have to fit the evidence to that belief. And that's a very dangerous way to go. You have to be prepared to throw out your belief if the statistics don't support it, but they reckon it does. There's a lot of overstatement in their stories. One of the things they do say is that a lot of the resistance to ideas about precognition and psychic phenomena is about fear, the fear of the unknown or the fear that things aren't the way they appear to be. I'd say that's, what's the most technical term? Rubbish? A lot of the resistance to the ideas is that there's lack of evidence for these things. The person making the claim has to prove it. The critic doesn't have to disprove it. The critic has to analyse the proof that's put forward. And the claimant, they often like to put the blame on the person they're talking to, but they've got to prove their case. And if they're just suggesting, you don't believe it because you're frightened of it.
Results for tomorrow now, and I'll believe you.
Yeah, no, it's as simple as that. But of course, it's not as precise as that, they'd say. The people are claiming that it's a memory being sent back from the future to us in the present so that we're going to experience something that's already happened, and that's what we're reacting to is just it's like a philosophical nightmare. The trouble is with this is that stories say scientists, and then you've got to seriously look about where the science is and who are they with. You've got to seriously look about what sort of scientists we're talking about. You can always find a scientist somewhere who will support the craziest ideas. Just because they're scientists doesn't mean they're immune from being silly.
That's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.